All right, we're going to look at Chapter 10, Lesson 11, dividing unit fractions by whole numbers. This is day 72. The two standards that this is aligned to is 5NF7A and 5NF7C. 7A is again conceptual, 7C is application, so in word problem contexts. The aim is students will be able to divide unit fractions by whole numbers using models. So yesterday what they did was divided a whole number by unit fraction. Today we're taking the unit fractions and dividing them by whole numbers. I'm going to open up the standards guide so that you can read these two standards. Again, it was 7A and 7C. Go ahead and pause the video right now if you want to reread these standards. Okay, so I'm going to go ahead and just look through our notes on the lesson because there's some important things I want to front load for you. Again, our students should never be using the keep, change, flip. We're not teaching them that this year. This is a conceptual standard, and if we teach them keep, change, flip, that is procedural, and they will not understand what dividing by a fraction means, or dividing a fraction by a whole number, what it means. So they should also check their work with multiplication. That's pretty clear. Okay, so one thing I want to share, two different models that I want to highlight. The book uses a model that looks like this. This is the problem 1/3 divided by 2. So they're taking this whole, it's green, and they're splitting it to thirds. It's these green lines right here. And then they're splitting each of those thirds into two equal pieces. So what we see is that we have 6 pieces in all, or 6 sections in all, which means that when I take 1/3 and I split it into 2 equal groups, there's 1/6 in each group. That's an okay model. I think it gets frustrating for kids when they don't have different colors that they can use. I also think that this model here that I said I prefer over the model below, I prefer this one because this matches our multiplication with fractions model completely. So what this is showing is 1/4. So like this problem is 1/4 divided by 2. This is showing 1/4. I shaded in the 1/4, and then I divided it into 2 sections. So this is the same as 2/8 divided into 2 groups, which means that I have 1/8 in each group. I'm going to say that again. This is 1/4 divided by 2. So I drew my whole and I split it into fourths. And then I divide it into 2 sections. So I split it then horizontally. What we see then is that we would have 2/8, and I'm splitting those 2/8 into 2 groups, meaning that I have 1/8 in each group. Okay, so that said, I prefer this model. There is, however, a PARCC example that we're going to get to. I included it as a right pair share after the 3 examples in our I&M, so that you actually see there is a PARCC example where I've seen this model or a model similar to this used. So our students need to be able to practice with both, and that's fine. Let's look at example 1. Autumn eats half of her snack and gives the other half to her 3 best friends for them to share equally. What portion of the whole snack does each friend get? So we start by drawing our whole and shading in 1/2. So we shade this in. And then we label this 1/2 shared with friends. She's sharing this 1/2 with 3 friends. So we're going to now split our whole into 3 sections horizontally. What that gives me is 6 sections in all. What each friend gets is one of those 6. So here the thinking is this is 1/2 divided into 3 groups. I wrote it in words, 1/2 divided by 3. When we split it here into now the 3 friends, we see that this 1/2 becomes actually 3/6. 3/6 divided by 3 is 1/6. So when I have 3/6 divided into 3 groups, there is 1/6 in each group. Here I can now write 1/2 divided by 3 is equal to 1/6. Each friend gets 1/6 of the original snack. To do our check, we do 3 friends. Each gets 1/6 of a snack. 3 over 1 times 1/6 is equal to 3/6, or 1/2. Again, like the check should match the word problem here. 3 friends each get 1/6. 3 times 1/6 is equal to 3/6. That leads us back to the original 1/2 that she shared with her friends. The next example doesn't have a word problem context. This is 1/6 divided by 2. So here we have 1/6. We draw our whole. We split it into 6 vertical sections. We shade in 1/6 of them. 1/6 divided by 2. We're splitting it now into 2 equal groups. So I had 1/6 divided by 2. That's the same as 2/12 divided by 2. When I take 2/12 and divide it by 2, that means I have 1/12 in each group. So 1/6 divided by 2 is 1/12. Our check again here at the bottom. Next one. This again goes into that word problem context. AJ made 1/4 of a gallon of lemonade. She pours the lemonade equally into 5 containers. What fraction of a gallon of lemonade is in each container? So start by modeling the 1/4 of a gallon. So 1 whole, we split into 4ths, we shade in 1/4 and we label 1/4. That's how much lemonade she had in all. She pours it into 5 containers. So we're splitting this now into 5 equal sections horizontally. This means I have 20 sections in all. Each container gets 1/4. This is 1/4 divided by 5, 1/4 divided by 5. This now 1/4 is actually 5/20. 5/20 divided into 5 equal groups is 1/20 in each group. Here we do a 1/4 divided by 5 is 1/20. And again, like the thinking is 5/20 into 5 equal groups, there's 1/20 in each group. 5 containers, each has 1/20 of a gallon. So 5 times 1/20, 5/20, that gets us back to our 1/4 of a gallon. Okay, let me show you really quick this next item. So I'm going to scroll down. This is going to be our right pair share. Cora has 1/2 of an hour to do 5 chores. She plans to spend the same fraction of an hour on each chore. She wants to use the number line to help her determine what fraction of an hour she can spend on each chore. What is the correct number label for A? Explain how to use this number line to help Cora solve the problem. What fraction of an hour will she spend on each chore? I'm actually going to now pull up the exemplar from Park. Same item from Park. We want students to be able to correctly label point A as 1/2 an hour or equivalent, and an explanation of how to use the number line. What that looks like is down here. The number line is divided from 0 to 1/2 in 5 equal sections because there are 5 chores. It would take 10 of these sections to divide the number line from 0 to 1. Each section represents the time she can spend on one chore, so she can spend 1/10 of an hour on each chore. What I would want from students is to look at this and say, well, from 0 to A is 1/2, and she can do 5 chores in that time. So if I recreated this model, I could see that she could do 10 chores in 1 hour. If I want to know how much or how long it's going to take her to do one of them, it's 1/10 of the whole hour because each one of these sections represents one chore. Okay,